Morning, students. I would invite Arun sir to start the session.
Thank you, ma'am.
Thank you, sir.
Hello, students. Good morning. Sleepy still? Harika, hi. Omkar, hello, hi. Rakshit is not responding. All right.
Yes,
So,
sir. Good
students,
morning.
yeah, Rakshit, for the past two classes, you're not responding at all.
Yes, sir. There
Seems
is a network issue.
okay. Okay, at least in the chat box, you can just respond.
Okay.
Huh? It seems like you just logged in and then disappeared. So, how will I know whether you're there? So, respond. All right. Okay. Students, we will do one thing today. Today is Saturday. We'll have class in the evening as well. We gave you a DPP on applications of derivatives, right? So I want you to try the DPP today after the class. It's a holiday today, right? Is it a holiday today?
No, sir.
No, you have a college today. All right. Harika, okay. So, but can you after the college, can you try those problems, or when you get a break time, can you try those problems so that tonight, I mean, not tonight, yeah, tonight we'll discuss those problems and complete the DPP. So now I will do applications of integrals. Instead of going for vectors further, I'll go for applications of integrals and complete the topic that was remaining in basic maths. So I would like to complete that today in this session. All right. So in applications of integrals, what we do is we basically find areas and volumes. Find area and volume of a surface and a closed surface. Volume enclosed in a closed surface and volume of the surface. Sorry, area of the surface and volume enclosed in the closed surface. That's what you basically find. So let's start with the basic, most simplest area, which is circle. What is the area of a circle? Of radius r. What is the area of the circle? It's pi r square. Right? Seems like everyone's sleeping.
No, sir.
Sleepy? Gayatri, are you sleepy now?
No, sir.
No? All right. Good, good, good. Rakshit, are you sleepy? Early in the morning, we are waking you up every day, not leaving a single day, no relaxation. That's what you're feeling? Rakshit, please respond. Omkar, good morning. All right. So we'll see how we get the area of the circle as pi r square. All right, let us using integrals, we'll derive the area of a circle as pi r square, and then volume of the sphere as 4 by 3 pi r cube, and so on. And volume of the cone, cylinder, and any such surface, we can do it using integrals. And this is very important for physics. So please follow this class carefully. I've got circle of radius r naught, and it's a planar figure, circle. Now I need to find the area of the circle. So what I do, I take concentric rings at a distance x. I take a concentric ring of width, small width dx. So width is dx and radius is x. Okay, it's a concentric ring. It doesn't seem to be concentric, but it's concentric. All right. Now, this part, this shaded part, what I do, I cut it and open it in the form of a rectangle. When I cut it, it's very thin. It's very thin, infinitesimally thin. ఎంత thin అంటే I've got millions of rings in between 0 and R. Let's say this is 1 meter. In this 1 meter itself, I've got millions of rings, such rings. సో ఇలాంటి చాలా రింగ్స్ నేను తీసుకున్నాను. ఇక్కడ ఒక రింగ్, ఇంకొక రింగ్, అలా రింగ్స్ తీసుకున్నాను. ఆ రింగ్స్ తీసుకున్నప్పుడు ఏరియా ఆఫ్ ఈచ్ రింగ్ ఇస్ హౌ మచ్ దట్ ఐ కెన్ ఫైండ్ అవుట్ యూజింగ్ వెరీ సింపుల్ జియోమెట్రీ. లెట్ మీ షో యూ హౌ. ది లెంత్ ఆఫ్ ద రింగ్ ఎంత ఉంటుంది? వాట్ ఇస్ ద లెంత్ ఆఫ్ ద రింగ్? Circumference of the ring 2 pi x. 2 pi x is the length of the ring. But when I cut it and open it, it forms something like this. Not exactly rectangle. You'll have a cut here, but almost like a rectangle. If it is very thin, it's almost like a rectangle. What's the area of this rectangle? Length into width. Width is what? Dx. And length is 2 pi x. So length into breadth is my area of this one. Right. Now what I do, I have to sum up all these areas from 0 to R. There are so many. The infinitesimal areas. There are infinite number of infinitesimal rings. This is called an infinitesimal ring because it's very small, so thin that opening it up, I can consider this to be a rectangle. All right. So area of this ring, area of the shaded region is 2 pi x into dx. When I integrate this from 0 to R naught, what I get is the area of the circle. So that would be 2 pi is constant, which comes out 0 to R x dx. What is integral x dx? X square by 2 2 pi is constant. Integral x dx is x square by 2 from under limits 0 to R. I substitute the upper limit first. 2 pi into
R
2
naught,
gets cancelled. Sorry?
R naught square.
Correct. Good. So pi into R naught square minus, I substitute the lower limit, 0 square, which is nothing but pi
R
R naught square, which I get the area of the circle. That's how I get the area of the circle. All right. So using integrals itself, we have derived the area of the circle. And what did I do in the integrals? I took a very small area, very infinitesimal area, very thin area. It could be a ring, it could be a strip or anything, but I've chosen a ring so that a concentric ring to this one, to this circle. I've written the area of this ring. What is the area of this ring? Length into breadth. What is the length of it? 2 pi x is the length, circumference is the length. 2 pi x is the circumference, into width is dx. So 2 pi x dx is my area of this infinitesimal ring. So I can write this as integral dA. So I'll get A as integral dA, which is equal to dA is how much? 2 pi x dx. Why is it dA? dA, we denote an infinitesimal area by notation as dA. And it's an infinitesimal area. When I integrate these infinitesimal areas, when I sum up, this integral sign comes from sigma, sum, S. It's elongated S. When I sum up all these areas, when I sum up all these small areas, what I get is a area of a circle. Right? Is it clear?
Yes,
Is it
sir.
clear to everyone? Okay, Gayatri, it's clear. Rakshit, is it clear? Omkar, Harika? You want me to repeat? I can repeat. Omkar and Rakshit.
Sir, Omkar has network issue. He
Okay.
is
All right.
asking to repeat
All right,
the
ma'am.
message. Yes.
All right, ma'am. Look at this. I have an area which is circular. We know it is this pi r square, but we need to derive it as pi r square. All right. So what I do, I segment this whole area, circular area, into concentric rings of width dx and radius x. As x varies, I get a bigger ring somewhere here. As x varies, I get another ring here. So I get so many rings, infinite number of infinitesimal rings. Very thin rings. When I cut it open, length is 2 pi x and width is dx. Okay. So what is the area of this strip? Area of the strip, circular strip is 2 pi x dx. 2 pi x dx is the area of a circular strip. Now I have to integrate this, sum it up. Integrate means other word for integration is summing up. I have to sum up all the rings between 0 to r, from smaller rings to rings which is of radius r, ring of which is of radius r naught. So I integrate this, summing it up from 0 to r naught. What I get is 2 pi is constant, it comes out integral x dx 0 to r naught 2 pi times integral x dx is x square by 2 under the limit 0 to r naught. 2 gets cancelled out. Pi times, I substitute the upper limit r square minus lower limit 0 square, which is nothing but pi r square, is my area of the circle. Is it okay now? Omkar, is it okay? Bhavna? Okay, good. Bhavna, hi. Hello, good morning.
Good morning, sir.
Yeah, what I'm doing now is applications of integrals. All right, I'm not going for vectors now. I'm doing applications of integrals, and in the evening we'll complete doubts on applications of derivatives DBP. All right, I've given a DBP having 10 problems only 10 problems. You will have to try this today, and by evening you please make an attempt. That was given a couple of days before. So I hope you have done at least a bit of it now, by now, partially. Complete that today. Evening, be ready with doubts. So we'll complete application of derivatives doubts in the evening. I'm telling this to everyone. And now I'm doing applications of integrals. In integrals, I'm finding out area of a circle. Area of a circle is pi r square that I found out using integration. All right. This approach is very important, students. ఇది పై ఆర్ స్క్వేర్ కదా మనం ఇది ఎంత ఎందుకు చేస్తున్నామని అనుకుంటారు, బట్ there will be cases where integration will come to rescue. Okay, now let us look at volume. I've got, this is a sphere. This is a sphere of radius r. I have to find out the volume of the sphere, which is 4 by 3 pi r cube. I know that, but I want to integrate it and find out. I want to derive it. So how do I do it? I chop this sphere with a plane, with a vertical plane like this. When I chop this with a vertical plane like this, what I get? What I get is a circle. This is what I get. If I section this with a vertical plane and a distance x, what I get is a thin plate, circular plate of width dx. So I'm chopping this sphere into infinite number of very thin infinitesimal discs. All right. So there are so many discs now. All discs circular like this. All right. Then what I do, I write the volume of each disc and then sum it up. As I've written the volume of this infinitesimal ring, I summed it up. I got area of the circle. Similarly, I will write the volume of the infinitesimal disc and I sum it up. When I sum it up, I'll get the total of all the discs. There are infinite number of infinitesimal discs. When I sum it up using integration, I get volume of the sphere. All right. I repeat, I've got a sphere. So this is a sphere actually. I section this sphere with a vertical plane like this. With a vertical plane like this, I section this sphere. I cut it like this. Like this. Like this. So when I section it like this, what I see is actually when I section this with a plane, what I get is a circle, right? The section of a circular sphere is a circle, but I want a thin disk at this juncture, at this place. So I take a thin disk of width dx. So at a distance x, I take a thin disk of width dx. So I have to find out the volume of this one. So if I look at it, that is nothing but a cylinder. What kind of cylinder? I've got area into height. Area into height. For a cylinder, what is the volume of the cylinder? Area of cross section into height, right? Similarly, I've got a very thin disk. Disk is nothing but disk is nothing but a cylinder of width dx and area this area, shaded area. So area into dx will give me the volume of the thin disk. So area into dx will give me volume of the thin disk, which is dV. If I sum it up from where to where? Where to where do I sum? My coordinate is going from 0. This is my x coordinate. My coordinate is going from minus r naught to plus r naught. So if I integrate this from minus r naught to r naught, what I get is the volume of the sphere. Now all I have to do is plug in the area of the disk. All that I have to do is plug in the area of the disk. If I plug in the area of the disk and integrate, sum it up, I'll get the volume of the sphere. What is the area of the disk? If this is r, this is perpendicular. Now this is my radius of the disk. This is my radius of the disk. Right? So r square minus x square under root is my radius of the disk. So r square minus x square under root is nothing but the area of the, radius of the disk. What is the area of that? We just now derived area of a circle is pi r square. Pi r square is my area of the shaded disk. So area into dx will give me dV, which is volume of the infinitesimal disk. If I sum it up from minus r naught to r naught, I get volume of the sphere. Let's see what do we get or not. Let's actually see what do we get. We are supposed to get volume of the sphere as 4 by 3 pi r cube. Let us see if we get it or not. So area into dx, pi into root of r square minus x square whole square dx, integrating it from minus r naught to plus r naught, is equal to, when I square and root get cancelled out because I'm squaring the root, so it becomes pi r square minus x square. Pi comes out, integral r square minus x square dx from 0 to, sorry, minus r naught to plus r naught. Why am I doing it from minus r naught to plus r naught? This is my origin. I'm measuring x from here. But my all the discs go all the way from negative coordinate to positive coordinate. They go all the way from minus r naught to plus r naught. Right? So this is my origin and x is my coordinate. My coordinate is ranging from minus r naught to plus r naught. So I integrate from minus r naught to r naught. I have to cover whole of the sphere. Wherever the discs are going, like I have to sum up all the discs. So wherever the discs are existing, I have to sum up all the discs. So discs are existing from minus r naught to plus r naught. So I integrate from minus r naught to plus r naught. So pi r square minus x square dx. What is r square dx? Students, r square dx. What is the integral? Can you integrate this? R square minus x square dx. How do you integrate it?
R naught cube by 3.
Okay. See, r naught is a constant, right? So r naught into 1 dx. Integral 1 dx is x. So it will be r naught x. Right? R naught square x minus, as you said, x cube by 3. Under limits, minus r naught to r naught into pi. This is my answer. Now I have to substitute plus r naught and then minus r naught. So what do I get? Pi times, I substitute plus r naught. I get r naught cube minus r naught cube by 3 minus lower limit. I substitute the lower limit. This becomes minus r naught cube minus r naught cube by 3. All right. So what do we get? No, there are certain very interesting things to learn in this integral, students. Integral లో interesting things నేర్చుకుంటాము. Okay, yeah. Who is it? Ma'am, any mistake over here? Like you are suggesting r naught square, I think.
That we have substituted the limits, no?
Uh-huh.
There. First one, it is R naught square x. Acha, okay, okay. Okay, so
R
it
naught
is
square
right,
into
sir.
x. R naught square into x. So r naught cube.
Yes, sir, it is right. It is right. Sorry, sir.
Yeah. No problem, ma'am. No, please let me know, ma'am. If at all there is anything, you please let me know.
Yes, sir, sure.
Thank you, ma'am. All right. Now there are, see, I'm doing it in lengthy way, but there is another interesting way to do it. All right. From here, we can bifurcate it into graphically and do it further easily. Now look at this. So identi minus 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 become plus. This is minus. So this goes away. This becomes plus. So this becomes plus of plus minus. So what does this become now? 4 pi r naught cube by 3. Simplify this further. That's what you get. You simplify this further, students. You simplify this further. What do you get? This is what I get. 4 by 3, 4 pi r naught cube by 3, which is nothing but volume of the sphere. Right?
So what
But
is dx? So what
sorry?
is dx? Dx. What?
dx. dx is nothing but the width of the disk. Infinitesimal disk. అది చాలా సన్న డిస్క్ తీసుకుంటాను నేను. ఈ స్పియర్ ని చాప్ చేశాను. I've done infinitesimal choppings. And each one is of disk width dx. Alright. So each circle, each disk is of width dx. So there are so many infinite number of infinitesimal disks. Infinite disks ఉన్నాయి, but infinitesimal thickness ఉన్నాయి. So dx is nothing but infinitesimal thickness. Alright, thickness of the disk. Volume ఎలా రాశాను? ఏరియా ఇంటూ డిఎక్స్, ఏరియా ఇంటూ హైట్. ఫర్ ఏ సిలిండర్, ఒక చిన్న సిలిండర్ తీసుకుంటే, సన్న సిలిండర్ తీసుకుంటే, if area is a, height is dx. So what is the volume? A dx now. For a
Yes.
cylinder, A dx is the volume of the cylinder, right? So similarly, volume of this disk, which is a cylinder, very thin cylinder, is nothing but area into dx. What is area? Pi r square. What is r? R naught square minus x square under root.
Yes, sir.
Is it clear? This is my radius. Pi r square is my area into dx will give me the volume. So pi r square into dx is the volume of the thin disk. నేను ఏం
Yes.
చేశాను? ఒక థిన్ డిస్క్ తీసుకొని దాని వాల్యూమ్ కనుక్కున్నా, దానికి సమ్అప్ చేశా. సమ్మింగ్ అప్ ఫ్రమ్ -r0 టు +r0. దీనికి సమ్అప్ చేస్తే నాకు కంప్లీట్ స్పియర్ వచ్చేస్తుంది. Alright, I am summing up. Integrating is nothing but summing up. In simple terms, it is summing up. Alright, now look at this, students. I'll wipe this out because it's very simple. Now let us look at it in a different way. Okay, now look at this. It is -r0 to r0, r square minus x square dx, right? So what is this r square minus x square? It's a graph. Area under the graph is my answer. It's a definite integral. What is definite integral? We have learned area under the graph. What graph? This function. E function graph ne neskunte, then area under the graph is my definite integral answer. So pi times integral r square minus x square dx from -r0 to r0 is nothing but is equal to pi times area under the graph. Which graph? R square minus x square graph. R square minus x square ఎలా ప్లాట్ చేస్తారు? నాకు x square తెలుసు. My parent function is x square, which is parabola. I do a minus x square to this. So reflection with respect to x axis, I get minus x square. Then I add r square to this plus r square. So I push it up by r square units upward. So this comes somewhere like this. So minus r0 to plus r0 square. This area is required. Pi into this area is my volume. Answer. Alright, understand this properly. Did you get this? What I meant by this? నేను ఇక్కడ నుంచి నేను ఇంటిగ్రేట్ చేయట్లేదు. నేను ఇక్కడ వచ్చాను, ఏరియా అంటే గ్రాఫ్కి వచ్చాను. నేను ఫర్దర్ ఇంటిగ్రేట్ చేయట్లేదు. నేను 2 times లిమిట్ సబ్స్టిట్యూట్ చేయట్లేదు. అది లెంతీ ఉందని 2 times సబ్స్టిట్యూట్ చేయట్లేదు. ఒక లాజిక్ యూస్ చేసి దానికి ఇంకా వన్ స్టెప్ సింప్లిఫై చేసేస్తాను. ఆ లాజిక్ ఏంటంటే, did you understand how I plotted r square minus x square? Did you understand how I plotted r square minus x square?
Yes, sir.
Okay, good. Gayatri, have you understood?
Yes, sir.
Okay, from parent function x square, I reflected with x-axis. I got minus x square. I pushed it up by r square units, upward, right? F of x plus a is nothing but I'm pushing it upward by r square units. So this curve. So this is a parabola. Area under this graph is nothing but this integral. This integral is nothing but area under the graph. But now look at this. This is symmetric. It has got a line of symmetry, where y-axis is a line of symmetry. My x square function is line symmetric function. Y-axis is my line of symmetry. Rotate చేస్తే మళ్ళీ ఆ ఫంక్షన్ వచ్చేస్తుంది. 180 degrees రొటేట్ చేస్తే y-axis ని పట్టుకొని, ఆర్ దీని మిర్రర్ ఇమేజ్ ఇది ఉంటుంది, దీని మిర్రర్ ఇమేజ్ ఇది ఉంటుంది. ఆబ్వియస్లీ దీని మిర్రర్ ఇమేజ్ ఇది ఉంటే
So what
దీని
is
మిర్రర్ ఇమేజ్ దిస్ వన్.
symmetry, sir?
సారీ.
Sir, what is symmetry, sir?
Okay. You were not there for symmetry class?
No, sir.
Okay, no problem. Look at this. Symmetry is nothing but try to understand today's class, students. It's very important for us. We cannot do this again and again. So please focus. And if you have any doubts like this, please ask. So, మెకానిక్స్ లో చాలా ఇంపార్టెంట్ మనం చేస్తుంది. ఇప్పుడు మొత్తం ఫిజిక్స్ లో చాలా ఇంపార్టెంట్. మీకు మోడర్న్ ఫిజిక్స్ వరకు ఇలాంటి ఇంటిగ్రల్స్ వస్తూనే ఉంటాయి. స్పెషల్లీ జేఈ వాళ్ళకి, అడ్వాన్స్ వాళ్ళకి చాలా వస్తాయి ఇలాంటి ఇంటిగ్రల్స్. ఇంటిగ్రల్ సింపుల్ ఉంటుంది, బట్ హౌ టు ఫ్రేమ్ అన్ ఇంటిగ్రల్ బి డిఫికల్ట్. సొల్యూషన్ సింపుల్ ఉంటుంది, బట్ ఫ్రేమింగ్ అన్ ఇంటిగ్రల్ బి డిఫికల్ట్. దట్ ఐఎమ్ ట్రైయింగ్ టు టీచ్ యూ. నౌ లైన్ ఆఫ్ సిమెట్రీ ఏంటంటే, ఒక గ్రాఫ్ ఇలా ఉందనుకోండి. ఒక గ్రాఫ్ ఇలా ఉంది. So this is, if I take this line, this is the mirror image of this one. Do you see that? This left side is the mirror image of right side.
Yes, sir.
So this line is called line of symmetry.
Okay, sir.
So every parabola has got a line of symmetry. For y is equal to x square, my y-axis is my line of symmetry. So every parabola has got a line of symmetry. Parabola is a line symmetric function. Any parabola, any damn parabola. ఏ పారాబోలా ఉన్నా నేను ax square plus bx plus c ఏ జనరల్ పారాబోలా తీసుకున్నా కూడా you will have a line of symmetry. A line of symmetry, about line of symmetry, this side will be mirror image of this side. So y is equal to x square line symmetric function ఉంది. లైన్ సిమెట్రీ ఇలా ఉంది. మైనస్ ఎక్స్ స్క్వేర్ చేస్తే కిందకు వచ్చింది, ప్లస్ ఆర్ స్క్వేర్ చేస్తే పైకి వచ్చింది, ఇలా వచ్చింది. సో దిస్ ఏరియా ఇస్ వాట్ ఈస్ రిక్వైర్డ్ ఆఫ్ దిస్ ఇంటిగ్రల్. ఇఫ్ యూ నోట్ దిస్ స్టూడెంట్స్, నేను మొత్తం ఏరియా కావాలంటే లైన్ సిమెట్రిక్ కదా, లెఫ్ట్ సైడ్ ఇస్ సేమ్ యాజ్ రైట్ సైడ్. అయితే నేను r0 నుంచి ఇంటిగ్రేట్ చేయ బదులు వాట్ ఐల్ డూ, ఐల్ ఇంటిగ్రేట్ ఫ్రమ్ 0 to r0. ఐల్ జస్ట్ ఇంటిగ్రేట్ ద రైట్ సైడ్ and multiply it by 2. Will it do? Will it be sufficient? I'll integrate from 0 to r0. I will get this area, but I want total area. I'll multiply by 2.
Yes.
Yes, sir.
है ना? Simple, no? You got the logic, right?
Yes, sir.
So when I substitute the limits, substituting 0 limit is very easy. Okay. Now, so what I do? 2 pi integral r square minus x square dx from 0 to r0. Now it's not minus r0 to r0, it's 0 to r0. So now what I get? 2 pi times r0 square x minus x cube by 3 under limits 0 to r0. Now what do I get? I substitute r0, r0 cube minus r0 cube by 3. 2 r0 cube by 3. 2 into 2, 4. 4 pi r0 cube by 3.
So how we get r0 square x minus
Okay.
by 3?
Okay. Yeah, look at this. Chapter. Integral a dx ఎంత ఉంటుంది? A is a constant, a comes out, you'll have 1 dx. What is the integral of 1? X. అంతే కదా, దీన్ని డిఫరెన్షియేట్ చేస్తే నాకు 1 రావాలి. డెరివేటివ్ ఆఫ్ x is 1. Integral of 1 will be x na?
Sir, integral ante sir.
Oh, integral, you were not there at all?
No, sir.
Oh, wow, now. Okay. You please attend the recorded sessions. Maths and physics. రెండిట్లో ఇంటిగ్రల్స్ అయినాయి. మ్యాథ్స్ లో కూడా చెప్పారు, ఫిజిక్స్ లో కూడా చెప్పారు.
Okay, sir.
Okay. So as of now, you just accept integral, accept చేసుకో. But have you understood this one? Why I have taken double the area?
Yes, sir.
You have understood why I have taken discs, infinite number of infinitesimal discs చేసి sum
Yes,
up చేస్తున్నాను. Okay. Have you understood why I have written pi r square, pi root of r square minus x square into dx,
sir.
area into dx? All right. Now look at this. So integral a dx is a comes out, it becomes ax. Similarly, I've got r naught square dx. So r naught comes out, r naught square comes out, integral 1 dx, which is nothing but r naught square x. Is it clear? Now
Yes, sir.
x square dx is nothing but x cube by 3. Right? This is fine now. X square integral x square dx is x cube by 3. That is why I got r square ke liye r square dx I got. X square ke liye I got x cube by 3. All right, these two functions I got for r square I got r naught square x. For x square I got x cube by 3. And I substitute the limit 0 to r. When I substitute r, I get this one minus 0. Because when I substitute 0, it is 0 into 0, 0 minus 0. So it doesn't matter.
Yes, sir.
All right. So we get 4 by 3 pi r cube as volume of the sphere. All right. Now let us see for volume of the cone. In all these cases, we are doing the same thing. Just that you have to understand how do I write the element. Element ఎలా రాసి Now I've got a cone. Cone is this way. Base radius is r naught. Height is h. R and h. All right. And I've got the axis of the cone as like this. This is a right circular cone. Now what I do? I chop this cone into infinite number of infinitesimal pieces again. So in a chop చేస్తే what I get is a circle. I'll take this as a very thin width dx. So at a distance x, I've got, this is my origin, at a distance x, I've got a thin disk of width dx. When I sum up all these volumes, I'll get the volume of the cone. All right. So what is the volume of this disk, thin disk? Area into dx. But what is area? This is my radius. So pi r square into dx. Now this is what I want. This is r naught. This is h naught. Now what is this radius? This radius is what I want ultimately. So how much is this radius? I'll use similar triangles. This by this, r by h is equal to question mark by x. ఇది question mark అనుకుంటే r by h, similar triangles, is equal to question mark by x. So question mark is equal to r naught by h naught into x. I got the radius. So what I do now? All I have to do is integrate these thin disks to get the volume of the cone. But what should be the limits from 0 to h naught? So what is the area of the disk? Let's write area of the disk now. Pi r naught x by h naught whole square into dx. I integrate this from 0 to h naught. I get the volume of the cone. So let's do further. So pi r square by h square comes out integral x square dx from 0 to h naught, which is pi r square by h square into x cube by 3. X cube by 3 under limit 0 to h naught, which is nothing but pi r square by h square into h cube by 3. So h square and 1 h square gets cancelled out. I'll get 1 by 3 pi r square h, which is nothing but area of the volume of this cone. Is this clear, students? All I did was I chopped it into infinite number of infinitesimal discs. I have taken the volume of one single disk and summed it up. When I sum it up, I integrate them. All right, that's the process of integration. Is it okay, students? అర్థమైందా ఇది?
Yes, sir.
Okay, now what I want, let us say instead of this whole cone, I just want my volume of a frustum. What is the frustum? When I cut this out, cut a part of the cone, and this is my frustum. I want the volume of this frustum. So what do? I integrate this from this limit, which is x1 or x0 to h0. ఇది x0 దూరం నుంచి స్టార్ట్ అవుతుంది నా డిస్క్. I will have to span all the disks in the volume. వాల్యూమ్ ఇంతకు ముందు స్పియర్ లో ఎక్కడి నుంచి ఎక్కడి వరకు వెళ్ళినాయి? -r0 టు +r0 వెళ్ళినాయి స్పియర్ డిస్క్స్. దీంట్లో ఎక్కడి నుంచి వెళ్ళినాయి? స్టార్టింగ్ లో కోన్ మొత్తం ఫుల్ కోన్ ఉన్నప్పుడు యూ గాట్ 0 to h0 వరకు డిస్క్ వర్ స్పానింగ్ ఫ్రమ్ 0 to h0. But now what I did, I've cut this part of the cone. I've got a frustum. This disk is now spanning from this level, from this value to this value. What is this value? X is equal to x0. What is this value? X is equal to h0. So I integrate this from x0 to h0, x0 to h0, x0 to h0. Under limits, you'll get the volume of the frustum. You're getting it? Okay. Seems like some network issue at their end. All right. Now, yeah, Gayatri, network issue. Yeah, Gayatri, is it okay now? Are you able to hear me, Gayatri?
Yes, sir.
Okay, you had a network issue there?
Yes, sir.
Okay. So you understood the frustum part? You understood why I took from x0 to h0?
Yes, sir. Because
So my limits should be, limits such that I should span all the disks, all the elements considered, all the infinitesimal elements considered. Now let's say I've got, have you ever seen plano convex lens? ఎలా ఉంటుంది plano convex lens? One side will be spherical, the other side will be plane. If I have to
Yes.
find out the volume of this one, if I have to find the volume of this one, how do I do? How do I find the volume of this one? So let the radius be r. All right. Whole volume is r 4 by 3 pi r cube. But I don't want whole volume. I want only volume of this part. This. Only this plane of convex lens. Let this distance be x naught. All right. Now what do? I chop this lens into infinitesimal number of discs. So I'll get a disc like this. And I find the volume of that disc and I integrate, sum it up. All right. What is the volume of that disc? I have to write down first. So at a distance x, ఇది one day lo raadu students. I am just teaching you how to do. I'll make you do some practice. Hell lot of practice. You'll be comfortable in this. So don't worry if you're not getting it in one go. ఇది రాదు, one go lo రాదు. All right. These are little complicated concepts. This will take time for it to seep in. All right. For it to get consolidated, it will take some time. So that's okay if you're feeling it very difficult. That's absolutely okay. But look at the strategy. Look at the procedure what you're following. I've got at a distance x, I consider a disk of width dx. So what is the radius of the disk? R square minus x square under root. R square minus x square under root is my radius of the disk. So area of that disk will be pi r square. Pi radius square into dx will give me the volume. I integrate this from, tell me the limits from where to where do I integrate? From where to where do I have to integrate to get this complete volume of the plane of convex lens? From where to where I have to integrate? It starts from x naught and ends at r naught. Yeah, Gayatri, go ahead. I couldn't hear you.
Yes, sir. It's from X naught to R naught.
All right, good. So x naught to r naught.
So
So
how
this will be the, sorry, Bhavna?
x naught to r naught how, sir?
Ah,
X
so now,
naught I understood, but r naught I can't understand.
that's okay. See, నాకు నేను మొత్తం స్పియర్ ఉన్నప్పుడు నేను ఏం చేశాను అక్కడ ఇలా డిస్క్ తీసుకున్నా కదా.
Yes, sir.
And distance x this తీసుకున్నా, ఒక డిస్క్ తీసుకున్నా. I integrated this from where to where? Minus r naught to plus r naught. Why? Because my discs are spanning from minus r naught to plus r naught. ఇక్కడ చిన్న డిస్క్ పెద్ద డిస్క్ మళ్ళీ చిన్న డిస్క్ ఆల్మోస్ట్ నో డిస్క్. ఆల్రైట్. నా ఇక్కడ ఏమవుతుంది? ఫ్రమ్ x naught నుంచి స్టార్ట్ అవుతుంది నా డిస్క్ స్పానింగ్. అండ్ దట్ ఈస్ ఎండింగ్ ఎట్ విచ్ పాయింట్? at distance of r naught కదా. This distance is r naught. ఈ డిస్టెన్స్ r naught కదా. రేడియస్
అర్థం
is it clear?
కాలేదు సార్. అదే అర్థం కాలేదు సార్. r naught ఎట్లా అవుతుంది సార్ అది?
ఏంటి భావన?
r naught అది కూడా మైంది కదా సార్.
r naught అది కూడా మళ్ళీ చెప్పు.
అది కూడా అయింది కదా సార్. r naught
r naught
సార్ డయాగ్రామ్ లో
ఇది r naught ఏంటంటే ఇది స్పెరికల్ సర్ఫేస్ కదా. ఇది స్పెరికల్ సర్ఫేస్ కదా.
ఎస్ సార్.
ఇది స్పెరికల్ సర్ఫేస్ ఉన్నప్పుడు ఈ రేడియస్ r naught అంటే ఇది కూడా రేడియస్ r naught కదా మొత్తం.
ఎస్ సార్.
సో ఇది x naught నుంచి ఈ లెవెల్ నుంచి ఈ ప్లేన్ నుంచి ఇక్కడ వరకు వెళ్తుంది. ఈ ప్లేన్ డిస్టెన్స్ ఎంత ఉంది? x naught. ఈ ప్లేన్ డిస్టెన్స్ ఎంత ఉంది?
R naught.
r naught సార్.
భావన, ఇస్ ఇట్ క్లియర్?
ఎస్ సార్.
All right. So I integrate from x naught to r naught. I'll get the volume of the plane of convex lens. But now let us say I want volume of దీనికి ఫార్ములాస్ లేవు. మన స్కూల్ ఎలిమెంటరీ లెవెల్లో దీనికి ఫార్ములాస్ లేవు. ఇంటిగ్రేట్ చేయాల్సిందే. వీ హ్యావ్ టు సమ్ ఇట్ అప్. So integration, Bhavana will do one thing. Evening, we'll take again. I'll do some integration again for you, but you better attend the recorded sessions and come back.
Okay, sir.
Okay, look at this now. But I don't want this plano convex lens. I want volume of this one, where central entry distance x naught, e distance emo, radius emo r naught. Radius r naught. ఈ ప్లేన్ సెక్షన్ చేశాను కదా, ఇది తీసేశాను. ఒక బౌల్, చిన్న బౌల్ ఉంది. స్పియర్ నుంచి ప్లేనో కాన్వెక్స్ లెన్స్ పార్ట్ తీసేశాను. Now I have to find out the volume of this one. So I'll again do the same thing. I'll take infinite number of infinitesimal discs of thickness dx such that at a distance x తీసుకున్నాను అనుకోండి, at a distance x I'll take a thin disc of width dx. దీని ఏరియా రాస్తాను, దీని ఏరియా ఇంటూ వాల్యూమ్ రాస్తాను, సారీ ఏరియా ఇంటూ dx రాస్తాను, వాల్యూమ్ వచ్చేస్తుంది. దాని ఏరియా ఎంత ఉంటుంది? I want to write the volume of the disc. So what is the volume of the disc? So at a distance x, I've taken a width dx. So what is the radius of this one? R square minus x square is my radius of the disc.
Yes, sir.
Pi into this one square, pi radius square is my area of the disc into dx will give me volume of the disc. I integrate it from, now tell me the limits. From where to where?
Sir, from x0 to r0.
x naught to r naught చేస్తే నాకు ఇదే వస్తుంది కదా, మరి ఈ రైట్ పార్టే వస్తుంది. x naught ఇక్కడ నుంచి ఉంది అనుకోండి, మరి నాకు రైట్ పార్టే వస్తుంది, ప్లేనో కాన్వెక్స్ లెన్స్ వస్తుంది. ఇంతకు ముందు కూడా x naught to r naught చేసాము, నాకు ఇది కూడా రావాలి కదా. నోట్, దిస్ ఇస్ ద కోఆర్డినేట్ యాక్సిస్. ఇది ఆరిజిన్, టువర్డ్స్ రైట్ ఇస్ పాజిటివ్, టువర్డ్స్ లెఫ్ట్ ఇస్ నెగటివ్. అయితే ఇది ఏమవుతుంది? మైనస్ x naught అవుతుంది. సో ఐ ఇంటిగ్రేట్ దిస్ ఫ్రమ్ మైనస్ x naught to plus r naught. All right, so it's a coordinate axis with origin at center. Coordinate axis తీసుకున్నా, ఆరిజిన్ నా ఇష్టం, నేను ఎక్కడైనా తీసుకోవచ్చు, బట్ ఫర్ కన్వీనియన్స్ ఐ టేకెన్ ఇట్ టు బి సెంటర్. నేను ఇక్కడ కూడా తీసుకోవచ్చు, ఎక్కడైనా తీసుకోవచ్చు, అది కూడా చేసి తర్వాత చూద్దాం. when time comes we'll do that, but now I've taken, for convenience I've taken origin to be at center. Axis ఇలా x axis ఇలా పెట్టుకుంటే this is positive, this is negative, so minus x naught to r naught. All right, is it okay?
Yes, sir.
I want hemisphere. అప్పుడు ఎక్కడి నుంచి ఇంటిగ్రేట్ చేస్తాను? I just want hemisphere.
Zero to 1.
0 to r0, sir.
Brilliant. మీరందరూ చాలా ఫాస్ట్ ఉన్నారు. This for the hemisphere. అయితే ఏమొస్తుంది? 2/3 pi r cube. All right, you will get that. If you simplify this, you'll get that. So that's not a big deal. ఇది సబ్స్టిట్యూట్ చేస్తే లిమిట్స్ ఇదే వచ్చేస్తుంది. All right, but now let us do this one for a cylinder. See, taking an element and framing the integral is crux of the problem. Solving the integral is not a problem. చూడండి, integral x square dx సింపుల్ కదా, x³/3. దాంట్లో ఏం పెద్ద లాజిక్ లేదు కదా. మీకు ఇంటిగ్రల్స్ కూడా ఇలాంటి సింపుల్ ఇంటిగ్రల్స్ వస్తాయి, బట్ ఫ్రేమింగ్ ద ఇంటిగ్రల్ ఇస్ crux of the problem. It's tricky part of the problem. All right, so that's why focus on taking the element and framing the integral. Solving the integral is very easy. X square by 3 or x cube by 3, integral x dx, x square by 2, అలాంటి చిన్న చిన్న integrals వస్తాయి. All right. So that's what I'm telling you. Solving part is very easy, but framing part is very difficult. But you people seem to be smart that మీకు difficult అనిపిస్తలేదు. Very good. You people are really smart. I really appreciate. Keep it up. Really good. All right. Now let us see a cylinder. Okay, ఒక సిలిండర్ వేయండి ఇట్లా. సో టాప్ వ్యూ ఎలా ఉంటుంది? సర్క్యులర్ ఉంటుంది. All right. This is side view. This is top view. Top view is of radius r, let's say. So radius r. Height h naught. So volume ఎంత రావాలి మనకి? Area into h కదా? Pi r square into h is my volume of the cylinder. That's what you have been using till now. Area into h. Right? A right circular cylinder. Area into h is my cylinder volume, right? I should get the same volume when I integrate also, when I sum it up also. Elements తీసుకున్నా కూడా same రావాలి నాకు. Now what I do, at a distance of x, I consider a thin sheet of width dx. This total is r naught. This is x. This is dx. So ఇది dx. This is x. And inside depth is h naught. This is h naught. And yesterday, one student was asking me, sir, values లేవు కదా నేను వాల్యూమ్ ఎలా కనుక్కుంటాను? నేను r ఇవ్వలేదు కదా నేను వాల్యూమ్ ఎలా కనుక్కుంటాను? So the answer is you will have volume in terms of r naught itself. Volume of a plano convex lens ఉంది. నేను radius of the spherical surface ఇచ్చాను, distance of the plane surface from the center ఇచ్చాను. So you can get the volume of the surface in terms of distance from the plane surface, x naught and r naught కదా? Right? In terms of x naught and r naught, you'll get the answer. అయితే ఎప్పుడు మీకు ఈ లెవెల్లో at JEE mains and advanced and NEET level you may not have numerical questions every time. You will have symbolic questions. Symbolic questions అంటే you will have symbols only and the answer will also be in terms of symbols in the question. Okay, symbols form లోనే ఉంటుంది. మొత్తం సొల్యూషన్ కూడా symbols లోనే ఉంటుంది. So you will have to work it out everything in symbolic form. So అలా you should get used to it. Numericals, when you get the answer numerical, just substitute the numerical. That's not a big deal. But framing the equation on the basis of just symbols, just the symbolic logic, not symbolic logic, it's just on the basis of symbols given in the question is the crux of the problem, is the trickiness of the problem. Akada you will have to use your brain. So you will not have numericals every time. Already remember that. That's what I was answering the student also. So I just got reminded of that. So I told you. All right. Now, what is the volume of this one? Volume of this thin sheet of width dx, height h and radius x. నేను దీనికి కట్ చేస్తే ఇలా కట్ చేస్తే ఓపెన్ చేస్తే I'll get this way a rectangular sheet. I'll get a rectangular sheet of width dx, height h naught and length 2 pi x. Is it clear? ఇది చెప్పండి నాకు. లెంత్ 2 pi x అర్థమైందా? హైట్ h naught ఓకే, నేను ఇలా ఓపెన్ చేశాను కాబట్టి హైట్ h naught ఉంటుంది. కానీ లెంత్ 2 pi x ఎందుకు ఉంటుంది?
Circumference of the circle.
Yes, exactly. Bhavana, is it okay?
Yes, sir.
Rakshit, are you there?
Yes, sir.
Are you able to follow, Rakshit?
Yes, sir.
All right. No, if at all you're not able to follow, please let me know. All right. So 2 pi x dx. So what is the area of this one? 2 pi x into h naught is the area. What's the volume of this one? 2 pi x into h naught into dx. Right? So 2 pi x is the length of that, as you said, into h naught is the area of that sheet into dx is my volume of the sheet of thickness dx. I sum it up from limits 0 to r naught. Why? Because my all these shells, cylindrical shells, these rings from top view are going from 0 to r naught. These shells are going from 0 to r naught. So they are spanning from axis, which is 0 to r naught. So what do I get if I integrate this? 2 pi h is constant, which comes out integral x dx from 0 to r naught. Integral x dx is how much? This is what you will get. Pi r square h. Right? R square is substitute, upper limit, 0 is the lower limit, it goes away. So pi h r square or pi r square h is the volume of the cylinder. Fine, this is fine. But now let us come to this one. Is it okay? Is this procedure clear?
Yes, sir.
Yes, sir.
All right. Okay. Now, this is a very interesting problem now. Now, instead of this complete cylinder, what I have is I have a part of a cylinder which is subtending an angle of theta at the center. Theta at the center. So I've got something like this. Where this is the axis of the cylinder, and this is being subtended. Now this is subtended at subtending an angle of theta naught. I want to find the volume of this one. So what do I do? At a distance of x, I consider an arc of width dx and height h. At a distance x, is it clear, students, or is it messy? అర్థమైందా ఇది నేను చెప్పింది? I know it
No.
is messy, but no, no. స్ట్రక్చర్ అర్థమైందా? ఒక సిలిండర్ది నేను ఇలా పార్ట్ తీసేశాను. పైన నుంచి చూస్తే ఇలా ఉంది సిలిండర్, కానీ పక్క నుంచి చూస్తే స్ట్రక్చర్ అర్థమైందా?
Yes, sir.
ఇలా ఉంది, పైన చూస్తే ఇలా ఉంది, స్ట్రక్చర్ నుంచి సైడ్ నుంచి చూస్తే ఇలా ఉంది. రైట్, సో ఐ గాట్ ఎ థిక్నెస్, సమ్ థిక్నెస్ from x0 to r0. The inner distance is x0, outer distance is r0. Right, now I have to find the volume of this one, and let's say this is subtending an angle of pi by 2 is for convenience. Initially, let that be pi by 2. So what I do at a distance of x,
Sir, ఏ వాల్యూమ్ కనుక్కోవాలి సార్ ఇప్పుడు?
ఈ వాల్యూమ్ కనుక్కోవాలి.
డిఎక్స్ ఉన్న థిక్నెస్ ది వాల్యూమా సార్?
ముందు dx ది కనుక్కుంటాను, దాన్ని ఇంటిగ్రేట్ చేస్తారు. ఇది టాప్ వ్యూ, ఇది టాప్ వ్యూ. పైన నుంచి చూస్తే ఇలా ఉంది. రైట్, పై బై 2 సబ్స్టెండ్ చేస్తుంది పై బై 2 అట్ సెంటర్. పైన నుంచి చూస్తే ఇలా ఉంది ఇది, కానీ సైడ్ నుంచి చూస్తే వర్టికల్ హైట్ h ఉంది.
సిలిండర్ పార్ట్ యొక్క వాల్యూమ్ కనుక్కోవాలా సార్?
అవును, సిలిండర్ ఒక పార్ట్ ది వాల్యూమ్ కనుక్కోవాలి. కానీ సిలిండర్ ఎలా తీసాను నేను పార్ట్? మొత్తం సిలిండర్ ఉంటుంది కదా,
ఎస్ సార్.
మొత్తం సిలిండర్ లో మధ్యలో సిలిండర్ తీసేసాను, ఇది మొత్తం మధ్యలో తీసేసాను, మరి 3/4 కూడా తీసేసాను ఇక్కడ. Just I'll tell you again, just a second. I had a complete cylinder. Top view of the cylinder is this one. ఇది r0, టాప్ వ్యూ, ఇది టాప్ వ్యూ. రైట్, లోపలికి వెళ్తుంది h0. దీంట్లో నేను లోపలి తీసేసాను. ఎక్కడి వరకు తీసేసాను? ఇక్కడ వరకు తీసేసాను. అంటే ఇప్పుడు ఎంత మిగిలింది? ఇది మిగిలింది. రైట్,
Yes, sir.
now in this also I'll remove this part. 3/4 I'll remove. Now I got this one. ఇది మిగిలింది. ఇప్పుడు దీని వాల్యూమ్ కావాలి. ఇది టాప్ వ్యూ ఆఫ్ ది సిలిండర్, సిలిండ్రికల్ సెక్షన్.
ఎస్ సార్.
దీని వాల్యూమ్ ఎలా అనుకుంటాను? at a distance x I consider width of the thin sheet of width dx ఇలా as an arc. All right, inner distance is x0, outer distance is r0. ఆరిజిన్ నుంచి ఇది x0, ఇది r0. సో at a distance x నేను dx తీసుకుంటే ఇప్పుడు ఇక్కడ కూడా ఇలానే ఉంటుంది కదా, థిన్ డిస్క్ వస్తుంది కదా. If I open it up, I'll get a rectangle again.
ఎస్ సార్.
That rectangle will be of width dx, height h0, and length ఎంత ఉంటుంది?
r0
r theta, pi by 2 into x.
Yes,
r
sir.
theta కదా, area or length of the arc is how much? Pi theta, r theta.
ఎస్ సార్.
So r is x, theta is pi by 2. So x into pi by 2 is my length of the sheet. Length, height and width అన్ని వచ్చేసాయి. ఇప్పుడు వాల్యూమ్ కనుక్కుంటాను. దీని వాల్యూమ్ కనుక్కుంటా. దీని వాల్యూమ్ ఎంత ఉంటుంది? pi by 2 into x into h into dx. I got volume of this particular sheet, thin sheet, infinitesimal sheet. Now where is it spanning from? From x0 to r0. So I integrate this from x0 to r0. I get the volume of required portion. ఇది అర్థమైంది అందరికి?
సార్, 5/2 ఎక్స్ ఎట్లా వచ్చింది సార్ అక్కడ లెంత్
ఇక్కడ లెంత్ ఇక్కడ
ఎస్ సార్
ఇది ఎలా వచ్చిందంటే చూడండి, ఈ లెంత్ ఎంత ఉంటుంది, ఈ లెంత్ ఆఫ్ ది ఆర్క్ ఎంత, ఆర్ తీటా కదా.
ఎట్లా సార్ అది
మీరు సర్కిల్స్ లో ఒక సర్కిల్ ఇలా ఉంది, ఆల్రైట్, ఇది తీటా సబ్స్టిట్యూట్ చేస్తుంది, రేడియస్ ఆర్ ఉంది, ఈ ఆర్క్ లెంత్ ఎంత ఉంటుంది, ఆర్ తీటానే కదా.
సార్ అది రేడియన్ కూడా అంటారు కదా సార్.
ఈ తీటా ఇస్ ఇన్ రేడియన్స్, అప్పుడు నాకు ఆర్క్ లెంత్ తెలిపి ఆర్ తీటా. ఆ రేడియన్ ఎప్పుడు అంటారు, వెన్ దిస్ ఇస్ యూనిట్ డిస్టెన్స్ యూనిట్ రేడియస్, అప్పుడు రేడియన్స్ అంటారు. వాట్ యూ సైడ్ ఇస్ రైట్, ఇది ఆర్ ఇస్ ఈక్వల్ టు 1 ఉంటే అప్పుడు ఇది రేడియన్స్ అంటారు, అదర్వైజ్ ఇట్స్ అన్ ఆర్క్ లెంత్. రేడియన్ ఇస్ ఆల్సో నథింగ్ బట్ ది ఆర్క్ లెంత్ ఆఫ్ యూనిట్ రేడియస్ circle of unit radius, arc length of circle of unit radius is radian, but ikkada radian kaadu, I am having a general r is not equal to 1 ikkada, so it is r theta kada, arc length. Is it
Yes,
okay?
sir.
Aithe idi x theta kada, x is the radius of this one,
Yes sir.
x theta, kani theta enti ikkada pi by 2, it is subtending an angle of pi by 2 anna kada, 1/4 తీసాను ఇక్కడ నుంచి. Is it okay, students?
Yes, sir.
Bhavana, is it okay?
సార్
Huh.
సార్ అది ఆర్క్ ని ఓపెన్ చేస్తే లెంత్ సేమే ఉంటది కదా సార్.
కరెక్ట్. ఈ ఆర్క్ ని ఓపెన్ చేశాను అనుకోండి, నాకు ఇలా రెక్టాంగిల్ వస్తుంది కదా. అయితే ఈ లెంత్ ఎంత వస్తుంది,
సేమ్ అంతే ఉంటుంది కదా సార్.
సేమ్ ఇంత ఉంటుంది కదా.
ఎస్ సార్.
ఇది ఎంత లెంత్, ఇది x is the radius, angle is pi by 2, so what is the length of this arc?
pi by 2 x సార్.
కరెక్ట్, pi by 2 x రాశారు.
ఓకే సార్.
ఓకే, యువర్ డౌట్ ఇస్ అబ్సల్యూట్లీ రైట్. అర్థమైందా మీకు ఇప్పుడు?
ఎస్ సార్.
ఆల్రైట్, సో pi by 2 x వచ్చింది, సో pi by 2 x is length into height into width. I got the volume of this infinitesimal sheet of thickness dx. దాన్ని I submit up from x0 to r0. Okay. Is it okay? I'll just do one more and then we'll wind up. Students, you're all tired?
No, sir.
No? Okay, good. Okay. Bhavana, Rakshit, Omkar. All right, another 5 minutes, we'll wind up. Because 2 hours at a stretch, 1.5 hour at a stretch, ఒకటే ఇంటిగ్రల్ చూస్తే you will go mad. Okay, now look at this. I want area of okay. If you try change మీరు, I'll just leave it as a homework. You just think of it. All right, I don't want the answer to this. I just want the integral. Integral solution నేను చేసేస్తాను. Don't worry. And that will be very simple. Exam లో వచ్చినా కూడా చాలా సింపుల్ ఉంటుంది. But framing the integral is only the crux of the problem. There lies the trickiness of the problem. ఈ సర్కిల్ ఉంది కదా, of radius r. I don't want the area of the whole circle. If I just want the annulus అంటే ఏంటి? Inner radius r, outer radius r naught. సారీ ఇన్నర్ రేడియస్ x0, outer రేడియస్ r0. దీన్ని యాన్యులస్ అంటారు. ఇది ఎలా తెస్తాను? How do I get this area? Outer area minus inner area, right? But let's say I need to frame an integral. Y integral, you'll get to know later. Why integrals are important, you'll get to know later. But let's say let's do this with integral. Integral frame చేసి limit substitute చేద్దాము. So what I do at a distance x, I consider a thin ring of width dx. So what is the, if I cut it and open it, what is the length of that ring?
2 pi r
2 pi x. Width of the ring?
dx.
Dx. So what is the area of this ring?
2 pi x in
Pi into
2
h
pi
dx.
2 by x dx. Now I sum it up from where to where? Limits. Now annulus కావాలి. Just ఈ పార్టే కావాలి నాకు.
x0 to r0, sir.
Right. I'll get area of the annulus. Fine. Well and good. It's so far so good. But now next cases ఇది అంతే వస్తుంది. ఇంటిగ్రేట్ చేస్తే నాకు పై ఆర్ స్క్వేర్ మైనస్ పై ఎక్స్ స్క్వేర్ వస్తుంది. మనం కామన్ సెన్స్ కూడా చెప్పొచ్చు పై ఆర్ స్క్వేర్ మైనస్ పై ఎక్స్ స్క్వేర్. కానీ కామన్ సెన్స్ పక్కన పెట్టి నేను ఇంటిగ్రేట్ ఎందుకు చేస్తున్నాను? You will get to know this later. When we enter into mechanics, you'll get to know. But that time we'll not have time to revisit all these things. ఇప్పుడు ఇదంతా చేయడానికి అప్పుడు టైం ఉండదు. Because by then you'll be using this in other subjects also. Okay, now I don't want this area. Annulus కాదు నాకు కావాల్సింది. I want this one. I have a circle. x0, r0. I want this area. This area cannot be done using common sense. This has to be done using integral. I want to frame the integral for this one. How do I do it? ఇది ఆలోచించండి. All right, what kind of element should I take? ఎలా సెగ్మెంట్ చేయాలి నేను ఇది? ఇలా సెగ్మెంట్ చేస్తే బాగుంటుందా? ఇలా సెగ్మెంట్ చేస్తే బాగుంటుందా? ఆర్క్ లో చేస్తే బాగుంటుందా? I can do any shape, but which is convenient for us. Now, after this, let us do this one. You understood this shape? I've got a cylinder. ఆ సిలిండర్ లో ఒక ప్లేన్ తీసుకొని కట్ చేశాను. సో ఇలా కట్ చేస్తే పైనుంచి సిలిండర్ ఇలా కనిపిస్తుంది, సైడ్ నుంచి h0 హైట్ ఉంది. All right, I have to find the volume of this one. After you get the area of this one, it's very easy to do this one. But framing an integral for area of this one is very little difficult. But after you do this, it's very easy. All right, let's see how to do that. ఈ షేప్ అర్థమైందా అందరికి?
Yes, sir.
Yes.
Okay. Why only 2 students are responding out of 4? We've got a very small class today. 4 students unnaru, but only 2 are responding. Why so? What happened to Rakshit and Omkar? All right. Now what I do, I have to find out that area, right? At a distance x, I chop this into vertical strips. Of width dx. At a distance x, dx. Inner distance is x0, outer distance is r0. I have to find out this complete area. So I find the infinitesimal area. I sum it up from here to here. From where to where? What is the limits? Where does x go from? This is my origin. X goes from here to here. What is x over here?
X naught, sir.
X naught to
R naught.
right. So my integral goes from summing up goes from x naught to r naught. Now all I have to do is write the area of this integral, area of the strip. ఇది ఎలా రాస్తాను? ఇది ఎలానే రెక్టాంగిల్ లాగానే ఉంది. నాకు లెంత్ ఇంటూ విడ్త్ కావాలి. విడ్త్ dx ఉంది. లెంత్ ఎంత ఉంటుంది? ఇది r naught అనుకుంటే r naught ఇచ్చారు. r naught స్క్వేర్ మైనస్ x స్క్వేర్ అండర్ రూట్. r naught స్క్వేర్ మైనస్ x స్క్వేర్ అండర్ రూట్. dx ఇంటూ 2 ఎందుకు? ఇక్కడ ఒక లెంత్ ఉంది, ఇక్కడ ఒక లెంత్ ఉంది. దిస్ ఇస్ r naught స్క్వేర్ మైనస్ x స్క్వేర్ అండర్ రూట్, r naught స్క్వేర్ మైనస్ x స్క్వేర్ అండర్ రూట్. సో ఇంటూ 2 into dx is the area of this one. Integrating it from x naught to r naught will give me area of the required shaded area, this area.
Sir, can you explain it again?
Yes. See, I've got this ఈ ఏరియా కావాలి నాకు. ఈ ఏరియా ఏంటి? ఒక సర్కిల్ ది ఒక సెగ్మెంట్ ఉంది. సెగ్మెంట్ చేస్తే ఈ పోర్షన్ ది కావాలి నాకు. So this we cannot do it with common sense. I need to frame an integral for this one. But framing an integral is what is the crux of the problem. I am repeating again and again. దీంట్లో I'll chop this into infinitesimal strips. Infinite number of infinitesimal strips. ఇలా ఇలా చాప్ చేస్తారు. అయితే ఒక స్ట్రిప్ వస్తుంది నాకు. ఒక స్ట్రిప్ ఆఫ్ విడ్త్ dx వస్తుంది. At what distance? At a distance x. ఈ డిస్టెన్స్ x దగ్గర what is the length of the strip? What is the length of the strip? R square minus x square under root. Pythagoras theorem for this triangle.
Yes, sir.
So r square minus x square. X naught మర్చిపోండి. X naught ఇక్కడ వరకే ఉంది. X naught ఇక్కడ వరకే ఉంది. But x is from here to here. So r square minus x square under root is the length of this one. By symmetry, this is also same length.
2.
Into 2. This plus this. This into 2. I get the complete length. This complete length into dx will be the complete area.
Okay, sir. I
I
understand.
integrate this from x naught to r naught. I get the required area. ఇదే ఇంటిగ్రేట్ చేయాలనుకుంటారు. దీనికి ఫార్ములాస్ ఉన్నాయి. ఆల్ రైట్. ఆర్ he'll give some more conditions, some more information such that this will also be simplified. ఓన్లీ మనకి ఇంటిగ్రల్ ఫ్రేమ్ చేయడమే కష్టం ఉంటుంది. దాని తర్వాత సింపుల్ ఉంటుంది. ఆల్ రైట్. సో లెట్స్ స్టాప్ హియర్. ఎనీ డౌట్స్ as of now?
No, sir.
All right. Idi, don't worry about it. It will look difficult, but I'll make sure that you master it. And this is very much required for physics. All right. నేను physics కి కావాల్సిందే చేస్తున్నాను. I'm not doing any mathematics here. I'm doing mathematical physics. Mathematics required for physics, broadly speaking. Right. All right. Not in a technical sense, but mathematical. I'm doing basic maths, which is math required for physics. So don't worry, don't be scared if you don't get this at one go, but you are all doing good. Trust me, the way you are responding, the way you are understanding things are really good. If you can keep this up, if you go at this pace, you are sure to crack very good rank in competitive exams. But you have to continue with this pace. Ide hard work, ide spirit, ide motivation chupiyali every day. All right, every day is required. Sometimes once or twice you may, your health may be bad, or some condition at home, or some network issues that may happen. But your spirit and motivation should be up the way it is now. All right. All right, students. And don't worry about it. I'll make you master it, but have patience. Please break ఉన్నప్పుడు ఈ రోజు మీకు క్లాస్ లో ఎక్కడైనా బ్రేక్ ఉన్నప్పుడు కాలేజ్ లో రివైజ్ దిస్. Just do all the integrals, whatever I've done, or not or, and you also have to do that DPP. DPP ని ఒకసారి అటెంప్ట్ చేయండి. అట్లీస్ట్ 3 ఎగ్జాంపుల్స్ ఉన్నాయి దాంట్లో. ఆ 3 ఎగ్జాంపుల్స్ అయినా చదివి రెడీ ఉండండి. దాంట్లో 3 ఎగ్జాంపుల్స్ ఇంకా 10 ప్రాబ్లమ్స్ ఉన్నాయి. ఆ 3 ఎగ్జాంపుల్స్ చదివి రెడీ ఉంటే we can attempt those 10 problems confidently. All right. I want to wind up the DPP today itself, evening session lo. All right. That's all, students. Thank you all and have a great day. Thank you, ma'am. Chandrika ma'am.
Thank you, sir. Yes, students. Thank you, students. 1 second.